Okay, so in English we say x equals u plus tv is the line through u that is parallel to v. Okay, how about a plane in R3? So how about just in R3 generally? In R3, I'm not going to try to draw the axes. It's not worth the time, to be honest. You want to just draw a non-literal diagram. So how about this? A line. A line would be same form. A is equal to u plus t v, same form. Now we're going to have a plane. If you have two so-called direction vectors, v plus, let's say, s times w. Okay, how we can think about we have to be careful if v and w are not parallel. That's one stipulation for the plane. Okay, so let's draw the plane here. So what I'm going to do is not draw the axes. It's going to be too complicated. So I'll just draw the origin and label it as a zero vector. So maybe I'll start with u. U is just some vector, whatever, like this. And we'll just put a little point there. And let's say we have, oh, it's an ugly arrow. V like this, and W like this. Now, what are we going to do? We're going to take W and shift it over to this point here. And then take V, and also shift it over. Something like that. Now to visualize this plane, what I do is I think about this triangle. Ooh. Think about this triangle here. That's a triangle there. So I want you to visualize this triangle kind of floating in space. Now, there is only one plane that contains that triangle, and that's the plane we're talking about. So in English, we'd say the plane through u that is parallel to both u and v. Okay, and sometimes we call these things direction vectors. Direction vectors. Vectors. Okay, so again, the plane, when we write this equation down, you have the origin here. You got the tip of your vector u here. And there's this triangle floating in space. The plane we're talking about here is the plane that contains this triangle.